All right, guys, here's this big old section, 8.7, these big problems involving all these different skills and pretty tough problems. I'm trying to point out things to pay attention to as you're going through and hopefully make it easier on you. So let's read over the question here first. We're going to find all the zeros of the function. It was this big old long function given that x minus 3 and x plus 5 are factors. So I want to just kind of point out what they're asking us to do first. They want us to find zeros. And so when we're done, our answer should look like x equals. We want to find those values of x that make y 0. And then what I want to notice too is here the degree of this function is 4. So when we're done, we should have 4 answers. So we should have x equals, x equals, x equals, x equals. And so just kind of thinking ahead like that. Next thing I want to do is notice what we're given. And so we have 2 factors. And from factors, we can find 0 values real quickly. And so here we know x equals 3. And the other one, we know x equals negative 5. So we actually have 2 of our 4 answers already. So that makes it really easy. And so the idea with this is if we can get rid of 2 of them, the 2 we know, we can focus on the 2 we don't know. And so we get rid of factors by dividing them out. If I know that 2 and 3 are factors of 60, but I'm not sure what the last one is, I would take the 60 divided by 2, and then that 30 that's left over and divide it by 3, and then I'd be left with 10. Say, oh, 10 is the final factor of 60 there in that case. And so when divide out these ones I know, so we're going to use our synthetic division to do that. We want to check for gaps. 4, 3, 2, 1, 0. No gaps. So I'm just going to run my coefficients over here. So I got a 1, I got a 2, I got a 3, and a 36. That's not a 6. And then a negative 270. So make sure you grab that sign. Box. And then I need to take one of those zeros. Doesn't matter which one. So these are factors. So I want to take the 0 of the factor. So I'm just going to grab that first one there, the 3. I'll use it first. We'll bring down the 1 all the way. So that's 1. 3 times 1 is 3. Add down 5. 3 times 5 is 15. Add down at 18. 3 times 18 is 30. 24, 54. Add down, it gives me a 60, 90. And 3 times 90 is 270. Add down, we get 0, which is what we need. Since that is a factor, it should come out evenly. Would make sense if it didn't. Since I have another one to do, I'm just going to drop another box right below that. I'm going to cross out that 0 there at the end, and I'm going to bring in that other 0, which was negative 5. The order doesn't matter. If I'd done the negative 5 first, these numbers here would be different, but then our final answers would be the same, so it doesn't matter. Drop the 1 down. 1 times negative 5 is negative 5. Add down, get 0. 5 times 0 is 0. Add down, get 18. 18 times 5, so 10 times 5 is 50. 8 times 5 is 40. That'd be negative 90, which is really good. There's that 0 again, so check on that one. So I need to turn this into a polynomial so I can keep solving. So I got 1x squared, and then plus 18. That's it. All right, no remainder. So there's our polynomial. I want to keep solving, so I need to write that as an equation. So I set equal to 0, so I can finish solving this guy. Now this is one of the easier ones since we only have one type of x. I'm just gonna go ahead and solve this like I SADMAP, right? Just get x by itself. So I'm just gonna get 18 to the other side. Get x squared equals negative 18. I'm gonna square root both sides. Get x by itself. So x equals. So since we just square rooted, we need a plus and a minus, a positive and negative. I have the square root of negative 18 here. Now a little red light should be blinking in your head because we just put a square root over a negative, and we need to simplify that negative. So that red light should be happening there because we just square rooted a negative, and so that's that tell us about our answers. there, so that's our answer's gonna be imaginary. So watch out for that. We also need to reduce our square root of 18. So I'm gonna pop up here, just sock that out, just worry about the 18, just holding on to that imaginary number idea in my head. So 2 times 9, which is 3 times 3. Need groups, pairs, buddies, gotta go outside. Lonely guys, stay on the inside. So just pop that up here. X equals, so group of 3, so 1, 3 comes out. Oops, forgot my plus minus. Dope. Plus minus. Group of 3's comes out. Now I got that imaginary number. Almost forgot it, but remembered. So since it's square root of negative, it's imaginary. Square root, lonely guy was 2. So plus or minus, that's not a 2. 3i radical 2 is 2 of my answers. So positive version, negative version, that's 2 of the answers. Remember we had the other 2 values from earlier. So x equals 3 was one of the answers. And x equals negative 5. So let's count them. 1, 2, 3, 4. 4 answers. Boom. Just like we said. 4 zeros. We got it. Let's try another one. On the other problem here, I would only expect to see 2 x-intercepts because 2 of the answers are imaginary. So we should, at most have 4 because the degree is 4, but we're only going to see 2 of them. We're only going to see these 2. These won't show up on the graph. So probably kind of like a parabola when we go to graph it. Just kind of a weird parabola, but both ends would point up and it would hit the x-axis twice and have like a vertex-y type spot down lower below the x-axis. All right, so now we are solving. So solving this equation, given we got 1, 0 here, so I can just kind of stop and thinking, what's it mean to solve? Well, very much like it means to find zeros, we're looking for, to find out what x is. The other thing I want to pay attention to is how many answers should I have? Right, I should have 3. So when I'm done, I should, x equals, x equals, x equals. So get that. So just like before, we want to get rid of things we know in order to focus on the things we don't know. So right off the bat, lucky us, they gave us one of the zeros, which means they are giving us one of the solutions. Zero solutions, x-intercepts, roots. All those guys are very, very closely related. So we already know one of the answers. Boom. So let's get rid of that one that we know to focus on the ones we don't know. Check for gaps. 3, 2, 1, 0. No gaps. Been a while since we've seen a gap. But they're out there. Watch out. So 1, negative 2, negative 72, 144. Our 0 is 2, so I don't need to change the sign. They didn't give me a factor. Drop the 1 down. 1, 2 times 1, 2. Add down is 0. 2 times 0, 0. Add down, negative 72. 2 times 72 is 144, and that's negative, which is awesome because that gives me 0. Remainder constant, x squared. So x squared minus 72 let's see, equals 0. So finish solving this. When I said equals 0, solve it. I guess so, like before, since there's only one x, let's go ahead and get this just, x by itself. So I'm just going to add 72 over. Plus 72, so x squared equals 72, square root both sides. So it means x is equal to plus or minus, whatever the square root of 72 is. So I guess we'll come up here and look at the square root of 72. 72 is 2 times 36, which is 2 times 18, which is 2 times 9, which is 3 times 3. It's all socked out. So here's our sock right here. So pairs, buddies. I got a pair of 2s. I also have a pair of 3s. And we got a lonely 2. x will equal plus or minus. Got a 2 and a 3 that are both buddied up. So 2 comes out and a 3 comes out, which gives me 6. And multiply, not add. And then radical. And then that 2 is left over. Boom. So there's 2 answers out of the 3 we knew we needed to get. And because there's our good old buddy 2, what we knew from before. So if I was going to look at the graph of this, I would expect to see all 3 x-intercepts because all of these are real. Even though these are irrational, it just means that the x-intercept's going to cross somewhere like in the decimal area between 2 numbers, whereas the x-intercept here would be right on 2. It's like, but I expect to see all 3 of these. Where the one would look more like that N shape, and hitting the x-axis 3 times. And one of them would be 2, and then the other ones would be these, positive, negative, 6 squared, 2, whatever those values are. So, alrighty, I'll see you guys later. Bye.